Greetings and welcome to the introduction to astronomy. In this lecture, we are going to continue talking about Venus, specifically this time looking at the atmosphere and some of the exploration of Venus that has occurred. So let's get started. What we know is we have explored Venus going back to 1962. Not that many years after the first satellites were launched into space, we had our first planetary encounter with Mariner 2 flying by Venus. In 1970, we had our first information from the surface. Now, while we can see Venus from Earth, we cannot see the surface. It is completely shrouded in clouds. And Venera 7 in 1970 gave us the first images of the surface of Venus. And you can see one of those here with all the rocky areas in the region where the Venera probe landed. Now, in order to see it in more detail, we need radar, and the Magellan craft orbited Venus from 1990 to 1994 and gave us detailed radar maps of the surface, allowing us to study the surface in detail for the first time. So Venus has been explored, but not as well explored perhaps as Mars we'll look at, or our moon, but probably better explored than Mercury. Although again, it is difficult in ordinary visible light because Mercury we can map the complete surface, whereas Venus we need to do that through radar, and to make visible maps we need to get down below those cloud layers. So what about those cloud layers in the atmosphere? Well, the atmosphere of Venus is very thick, and that prevents us from seeing the surface either from Earth or even from orbit. So we actually have to go down below the cloud layers in order to see what the surface looks like. Its composition is quite different than Earth's. It is 96% carbon dioxide, 3.5% nitrogen, and little bits of other compounds, including things like sulfuric acid, highly corrosive compounds. Now, this is one of the reasons it's been very difficult to land and explore the surface of Venus. It has a temperature that is not conducive, and a lot of corrosive compounds. So it has an extremely high pressure, 90 times Earth's pressure. How do we relate that? Well, that would be about the equivalent of a kilometer below the ocean's surface. So if you go down a kilometer in the ocean, the pressure of all the water you feel there would be similar to what you would feel just standing on the surface of Venus. It also has a high temperature of 700 Kelvin. So high temperature, high pressure, corrosive compounds. This craft that do land on the surface don't last a very long time. So while we've had a few pictures, most of the studies of Venus have been done from orbit. Now let's look at the atmosphere in a little more detail here. And here we can see the breakdown of what we see for Earth. This we've already looked at as compared to Venus and as compared to Mars. So we'll come to Mars later on in these lectures. But we see Venus, there's a big difference in the amount of carbon dioxide. Venus's atmosphere almost completely carbon dioxide, as is that of Mars. Nitrogen, very prevalent in Earth, is much less in the other two planets, as are some of the other compounds, especially of course oxygen. Oxygen very rare in Venus, pretty rare in Mars. Neither of them anywhere near an amount that we could breathe, but very prevalent in Earth. So let's look at a sketch of this and see how the temperature varies. There we see the extremely hot temperatures on the surface, over 700 kelvins. And to put that into perspective, that is that's about twice as hot as an oven on a very high temperature. So if an oven is set to 400 or 450 degrees Fahrenheit, we're looking at close to double that on the surface of Venus. Now the bottom area is actually relatively clear. So if we look down here, this is very transparent. You have nice clear skies when you get down below. However, we have all of these clouds here, sulfuric acid clouds, which make it difficult for anything traveling down through the atmosphere, as you would have to pass through those, and those would have a corrosive effect on the anything coming through there. So sulfuric acid will dissolve some metals. So certain metals and electronic equipment would be damaged by that. And then you get further up above and we see that the temperature does decrease to something a little closer to what we're used to seeing as you rise up and get higher up towards these clouds and gets to something closer to what we have in Earth's atmosphere. But the surface temperature is incredibly high. Why? Why does Venus have such a high temperature, making it the hottest planet in the solar system? Well, the temperatures were measured and this was kind of a surprise that at 800 degrees Fahrenheit, 700 Kelvin, that was the temperature when this was hot. Well, this is again the greenhouse effect. So we see the sunlight coming into Earth. Some is reflected back to space. Some is absorbed and re-radiated as heat. So the heat is what warms the earth. The little bit that some is it absorbed by those greenhouse gases. Now remember that Venus has a very high percentage of carbon dioxide. Carbon dioxide is one of the greenhouse gases and therefore insulates Venus, keeping a lot of the heat in. It's got all of those clouds again that increases the heat. So it is essentially what we're going to call a runaway greenhouse effect where the material runs away. And this is again similar to what happens to Earth, but much stronger because of that higher level of carbon dioxide in the atmosphere. So I said this is what we call a runaway greenhouse effect. So why is Venus so hot? Well, we call it the runaway greenhouse effect. Venus may have once been very similar to Earth. It may have had oceans many billions of years ago. However, it was closer to the sun and any increased temperatures would have caused more water and more carbon dioxide to be put into the atmosphere. As we know, these are both greenhouse gases, so they would help retain more heat, warming things up. And that would cause more water to be evaporated from any oceans that existed. Now, how do we get water, get rid of carbon dioxide on Earth? Well, some through living organisms, some through or much of it through the oceans. So a lot of carbon dioxide is absorbed in the oceans and becomes carbonate rocks and therefore is trapped and kept out of the atmosphere. If you lose the oceans, lose more ocean, and there's less water to then get the carbon dioxide out of the atmosphere. And you're continuing to put more and more of these greenhouse gases into the atmosphere. And it amplifies this. So it continues this. More heat is retained until eventually, again, an equilibrium is reached. So Venus does not continue to get hotter and hotter and hotter. It's reached a kind of balance where enough heat can escape to balance that which makes it through the clouds. Could water have existed in the past? Possibly, and probably likely that there was water that Venus could have had as much water as Earth. So it's quite possible. So are we seeing Earth's future? Well, in the short answer, yeah, we are seeing Earth's future. Regardless of what goes on with climate change, the sun is continuing to heat up and will do so. Now, this will take hundreds of millions of years, but over the next few 100 million years, the Earth will continue to warm and more water will then be released. And it's quite likely that the Earth will go through something much like Venus and become uninhabitable in several 100 million years. So let's go ahead and finish up with our summary. And what we've looked at this time, first of all, Venus is explored by a good number of spacecraft. We looked at a few of them here. We talked about Venus's extremely thick atmosphere, mostly carbon dioxide. And how did it get so hot? We call that the runaway greenhouse effect, that it has heated Venus's surface to extremely high temperatures. So that concludes this lecture on Venus, atmosphere, and exploration. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.